Is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to our webinar, How to Manage Large Numbers of Databases with Small Numbers of Staff. Devin, can you take it from here, please? Devin seems to be having some technical difficulties, so I will step in for him. Welcome everybody to How to Manage Large Numbers of Databases. Today we're going to discuss issues that arise from a sprawling data environment and from having large numbers of SQL servers, and some of the SAS solutions that are available to help overcome them. Here at Soaring Eagle, we specialize in making sure your data is maintained, accessible, performs well using an onshore team of database gurus. The first of our two presenters is Jeff Garbus. I am the speaker right now. I've written about 20 books, I've done lots of webinars, and I do speak at a lot of events. I've been working as a DBA professionally for over 30 years and founded Soaring Eagle about 20 years ago. Following me, we're going to have a speaker from across the pond, an IT entrepreneur from Finland. He's been servicing the SQL community with the solution for many years and is an expert at automating many of the day-to-day needs of your data environment and providing unique solutions to the problems we all face. He's the CEO of DB Pro, and in his spare time, he's the chairman of PASS in Helsinki. Jani, I'm going to completely blow your last name. Jani Savolainen. Please correct me and tell people how to say your name.
That was exactly correct. Jani Savolainen. Thanks.
Beautiful. So I'm going to go ahead and kick this off. The idea behind our presentation today is that we have dealt with data growth in a big way for some protracted period of time, and it sort of crept up on us. And companies that used to think that 20 gig was a lot of data, and then 200 gig was a lot of data, and then 2 terabytes was a lot of data, are suddenly dealing with 20 or 200 terabytes of data. They've gone from 2 or 3 servers to 20 servers or 50 servers or 100 servers, but their budgets for staff are not always going up. The requirements for management are frequently going up. The requirements from the federal government, from PCI, from HIPAA, from you name it, are frequently increasing. So there are a lot more tasks to perform and generally a lot fewer people to manage it. So first, let's talk about the individual problems. Things like keeping versions up to date. We recently onboarded a new managed services customer that had 137 servers, and they literally had every version and service pack of SQL Server from SQL Server 2000 RTM, SQL Server 2000 SP1, SQL 2000 SP2, all the way up through SQL 2017 running on Linux. So just the idea of keeping all of those up to date, keeping the servers to the most recent service pack, much less the OS pieces up to the service pack, is non-trivial. Keeping all of your servers up and running, knowing that they're all up and running. If the server fails, are you the first person to know it's down? Have you identified the components? Is a heartbeat registering? If the heartbeat is up and you can't get to the server, is that the problem? Are you able to get to the server but nobody else is? Creating this type of consistent environment, particularly within the limitations of the third-party software vendors that are telling you that the software you bought will run under SQL 2012 but not under SQL 2014 yet, or they're not going to certify it, can be a challenge. On the standard database support piece, we as production DBAs run into a variety of challenges. So for example, part of the preventive maintenance that we'll run on a daily basis includes database consistency checks. If we're running database consistency checks on 130 servers, we need to make sure that each of those runs. You don't have 100 people checking them every morning or whatever frequency it is that you're looking at it. So these types of tasks need to be automated. Things like index rebuilds and update stats. Many of you may have downloaded all the Holmgren scripts and have the process automated, but there is still the process, the separate and distinct process of making sure that process ran, that it ran successfully, that it had enough time to complete, that it completed successfully, that it didn't kick off errors. And 100 index rebuild scripts across 100 servers puts out a lot of messages. Things like backups, particularly transaction log backups. If you're running a transaction log backup every 15 minutes across, say, 10 to 20 databases per server across, say, 100 servers in your organization, you've got thousands of messages that are coming on a daily basis telling you that it was successful. Do you not have success messages? Maybe you only have failure messages. But what if the message itself fails to show up? That is in and of itself a problem. Things like performance alerts. Well, many of us get a separate message for that, but is it sufficient? Are we managing capacity appropriately? Well, sometimes the network team takes responsibility for that, but they have a different perspective about capacity than the database folks do. We know how fast the databases are growing, and that may be a little bit different from the way that the space is growing out in the disk. We need to be able to answer the question, how big is this going to be in 6 months or a year, simply for planning purposes. Now, most of the time, this information is coming back from us via some sort of email, because that's how SQL Server is set up and that's how a lot of the other DBMSs are set up. So what ends up happening is we as DBAs get hundreds to thousands of messages a day. I was at a client site recently where I was set up as a DBA, and over the course of 1 month, I had 120,000 email messages, and I defy any of you to even open 120,000 email messages in a month, much less reply to them or act upon them. We also need to start taking the next step. In addition to things like running preventive maintenance, we also need to be proactive. We need to take a look at existing performance. We need to ask the question before the users get in, are the users doing what they need to do? Is the performance sufficient? Is the database engine tuning advisor recommending the addition of indexes? Have we looked through the indexes to make sure that of the 10 indexes that it recommends, we really only need one because the other 9 are so similar that it's not relevant? Have we gone to identify those indexes that are not used? And once again, 100 servers times 8 to 20 databases per server, are we looking at the index utilizations in 1,000 databases across our servers? It's simply impossible to do all the proactive work without a tool to help bring this in unless you have a huge number of people and a huge number of eyes on the system. Now, as we start talking about things like performance and about the questions of should we have this many servers to start with, I'm going to leave those to Yanni, and he's going to talk about things like aggregation and data sprawl. What I'm going to talk about, though, is a mechanism to actually manage the number of servers you've got, because you need to be able to go in and identify what everything looks like. So things like automating your health checks is one of the things that we do on a regular basis. So if we have a tool that goes in and asks the question for each database, do we have missing indexes? Do we have job failures? Do we have unused indexes? Now, I'm not suggesting that you take a look at an unused index report and start dropping indexes, but we also have the capability of asking the question, has this index been used in the last week, month, year? And as these things start to add up, we can say, all right, based on space used or how big the sum of the index scans, index updates, etc. are, we have the ability to report on this and do lookups without having to go out to the individual servers, without having to RDP in, without having to run queries, without having to copy and paste the results, without having to pop them into spreadsheets, because it's all in one place. We also have a variety of verifications that we perform on a regular basis. So does your DBA have the time to go ask questions like, do you have VLF issues in your database? This is one of those insidious things that makes your I/O look slow when it's not necessarily slow. And we have quite a few of these warnings, and we keep adding these on a regular basis as new releases of the server come out and we run into problems that are specific to user releases. So we ask questions like, are the pages aligned? Are we using auto shrink? We should not be using auto shrink in production systems generally. How about auto growth? If we have a lot of auto growth going on, what we need to be able to do is take a look at this and ask the question, why are we growing? Should we be making this bigger? Is this growing unexpectedly? And if you have 1,000 databases out there, it's really hard to ask this question for each one without a tool. Other simple things. If we have a busy server and 30 processors, are we using one temp DB data file? We may need multiples for performance reasons. VLFs, are the deadlocks popping up? Are the I/O issues popping up? Even if you're tracking these, having emails come in when you're already getting hundreds to thousands of emails doesn't get you the information that you need. In addition to these, we also take a look at the drive space on each of the servers. Once again, 100 servers, can you monitor this on a regular basis? If you're always going out there, RDP to the server, bring up the file system, right-click on it, your network team may have an ability to do it, but do they do this on a regular basis? What we can do is go out, take a look at the servers, analyze them. We also have a separate tool that does predictive analysis and predictive growth. So the spot check will ask the question, do we have enough drive space right now? The predictive analysis, which we'll look at in a few minutes, enables us to answer the question, what's it going to be soon? How fast is it growing? And what can we do with it? Within Flight Center, we have the ability to create task lists, to assign them, to ask permissions, to automate the reviews, to bring in questions of what servers have been performed, what tasks have been performed on which server, to identify the tasks per server, to identify the tasks per assignee. So not only can you identify what needs to be done in a relatively quick way, you can assign it and follow it and identify that the tasks have been performed. So you have the identification, the assignment, the follow-through, and then the verification that they're complete. Now within Flight Center, one of the other beautiful things that we have is this environment page. The idea behind the environment page is that you can, at a glance, ask the question, how healthy are my 200 servers? This is the Soaring Eagle data, and we only have 3 servers running because in-house we don't have an awful lot of work. But we can quickly look at this and simply by color code look and see that we have a disk capacity alert on the Soaring Eagle server. We can take a look at the differential backup on the Soaring Eagle dev server and identify that we haven't received data. We have a variety of color codes here. The gray says we are not using this. The green says all is good. The blue says we're waiting for information. And the red says you've got an alert. In real life, we can hover over the red, get some information on it, click on it, go right to the event that kicked off the capacity. This is a great way of being able to identify in multiple servers that you have a couple of spotty problems and go and identify them before they snowball or before somebody calls you to tell you you've got a problem. It's really nice when there is an issue for when people call, you can say, yes, I'm already working on that. I've identified it. This is the problem. It'll be solved in a couple minutes. The top center, we've got a variety of icons that tell us everything from whether we've got issues to finding resources to who's online and who's on call. Within that environment module, we also can track on a per server basis. Sometimes we ask the question, what versions are we running? What versions of the operating systems have we got? What is the level of criticality of the server? So that, for example, if it is a production server and it goes down at night, we want to be woken up. If it is a dev server, we may choose not to be woken up. Now, if it's a dev server in India and you're in the US managing it, you may want to wake up and fix it because that's going to affect the appropriate people. So we can identify what causes or creates emergency calls. We can identify what version of software is running, what version of our modules are running, when we've had health checks, when we've done the admin reviews, when we've done the performance work, and again on a per server basis. So I'm not going to go through all of these tabs, but what you can see is that there is a selection of information, capacity, contacts, notes, failed jobs that we can perform on a per server basis or a per client basis. Now, we also have a very granular way of asking questions along the lines of what types of alerts and monitoring are we doing on a per server basis? So for example, I may choose not to monitor backups or DBCCs or index rebuilds on a reporting only server. I may not want to perform full log or differential backups. I may say, you know what, for this server or this database, I've got 15-minute differentials or 1-hour differentials so that if it's 5 minutes late, I know it, I can send an alert, but I'll send different alerts based on the frequency of those backups and have the ability to configure them. We can take a look at the backups. Sometimes your question is, have I backed this up lately? Every once in a while, you'll look at a list of the databases on a server and not realize it until you see it. The database simply hasn't been backed up. This is generally a bad thing. We record the backups, the intervals, the retentions, transaction log, differential backups, everything having to do with the backups here on the backup tabs. Finally, we have our capacity analysis component. Within the scope of the capacity analysis, what we can do is identify what the current capacity is, but also predict it. We gather capacity on a daily basis. We perform a regression analysis. And this gives us the ability to say that, based on the beginning of our examination period, and we use the last year, and based on what we've got currently, we're growing at about 8% or 2%. Based on these numbers, we can predict the target date when this is going to be full. This is something that most DBAs don't have the ability to do. They simply know that it's growing and they're starting to run out of space, but to be able to take the math and go to the network admin and say, you know what, this drive is going to be running out of space in about 3 months, you need to allocate more space, or buy more drives, or acquire more storage, very useful. We can determine whether we're going to generate alerts based on this, what our threshold is, and set up notes so that as we're setting up the alerts and the thresholds, we can tell the other person behind us, I care about this because, or I don't care about this because. Finally, Flight creates reports that allow us to come in and say, this is what we've done lately, this is the work that's being done on the server, this is the work that's being done on the client. These are the open events, and this is very useful, particularly for management, to be able to come and ask, what have you done for me lately? And this gives you an answer. So, short set of problems, lots of little pieces to put together for managing lots of servers, short version of solution. Flight automates many of the tasks of absorbing whether the information has come in, identifying if the information doesn't. If the backup failed, is it because the email didn't come in or because your SQL Server agent is down? Identify failure of any of the jobs quickly and move forward. So I'm going to pause here and turn this over to Yanni. Yanni is going to talk about SQL Governor and how his product enables you to look at large volumes of servers and ask the question, are we even using these? Should we combine them? And other information that I'll let Yanni share with you. Go ahead, Yanni.
Thank you, Jeff. I'm just trying to share my screen here.
No, don't share yours. Just use mine and click on it. I've given you the mouse control.
Okay, wonderful. So here we are. So, well, first I want to tell you a bit about the Scatter data platform. So, for example, Jeff's example that you have ended up into a situation where you may have for example, 100 servers, and each of these SQL Server have their own operating system. They have their own maybe physical hosts even, and you end up actually patching quite many servers, and you have a lots of different kind of data that you need to know about those servers. So it's quite cumbersome to maintain. Also, the license and hardware costs are higher, and you need more rack space. The energy consumption is higher. Everything is basically more expensive and takes more time, is tedious. So then what happens if we are going to consolidate these SQL servers? So basically, first thing that you're going to have is, for example, if you have 100 SQL servers and you're going to consolidate them into, for example, 15 to 20 servers. So this means that either hosts or then SQL servers by themselves, by restacking the SQL Server instances, if that is the case in your environment. So you need less administration work. There is much lesser operating systems and also servers to look after, and it's much more easier to monitor the whole infrastructure there, and you will get significant savings by licensing, by hardware, by energy consumption, and I'm going to tell you why it is. So here you can actually see the SQL Governor, our software capacity planning methods. And there exist 3 kinds of capacity planning methods that you're able to apply for your current data platform. So the software is actually capacity planning software. It does many other things as well, but it's not migration implementation software. So it creates a plan for you how you should do this migration planning. So the server level right sizing basically means that you are having a certain server, and then you want to know that what would be the optimal target hardware or target virtual machine or Azure VM, what is your target that you're going to have for next, for example, 3 years, 5 years, whatever is your life cycle you want to have for that. And our software has very smart algorithms that are able to deduct that what is the ratio in terms of benchmark between the source servers and target servers. So the CPU is much more efficient in newer generations of hardware. You don't need that much hardware. And also you're able to deduct how much IOPS on database side you need, throughput megabytes per second, read, write, total, latencies, allocated and reserved database and log space. All these are trend extrapolated over desired time span. For example, for next 3 years, it depends how you are going to plan that. So all that is calculated automatically and generated as so-called extrapolated time series based on these trends. And then you are able also to make the server level consolidation, which means that you're able to create the physical host and then hypothetical physical host, and then just drag and drop these your existing workloads into that host and see how the virtual machines are stacked there and how they consume the workloads over time. So in this way, you have a peaking CPU component as a different component with trend extrapolations. You have average CPU component, you have RAM usage, and of course all the database-based performance counters that are taken in count there. And in that sense, you can really see that which is the perfect fit for your becoming environment. And then the most efficient is the instance level consolidation. So this method is actually, we have our own IP on this, and what it does, it's basically it finds out with machine learning automation that which SQL Server instances should be logically put together in order to minimize the sleeping CPU cycles and to minimize the RAM consumption over time, over desired time span in the target platform. Therefore, minimizing the CPU core count and also the minimizing the number of target hosts when you are using the bigger hosts and bigger virtual machines in the target environment. ending up to a significant savings without sacrificing performance or availability of the system. So this is as a side effect that has been seen in many environments. We have actually averaged 44% savings in our customer cases so far. Okay, so next I'm going to show you some excerpt from the software itself. So here you have target topology of the environment that you're going to create. So you can see that how many physical servers you had before the capacity planning, how many servers you need after that, how many virtual servers before and after, and also what it means in terms of licensing. So you can get some kind of approximate of that okay, how much savings would I get here if I do this? And we are able to select just different kind of templates to target platform, and those templates, each individual template will generate different kind of topology, or would say target architecture. There can be active passive servers, standalone servers, and all those servers can have different baselines, threshold levels for the performance counters. For example, that the peaking CPU should never exceed 60%, average CPU should never exceed 30% during the life cycle of this particular server. You can have a technical service level there, and different kind of constraints, test, development, production, so on. And then the machine learning automation calculates you the optimal setup for the target platform. So it cannot be easier to do this quite a cumbersome and tricky manual process to do. If you try to do this manually, for example, only having 10 SQL Server instances and try to fit them into all possible logical combinations, it's actually permutation calculation. It takes about like 3.6 million different logical combinations of instances. You don't want to make it by hand there. Okay, so then what else I'm going to tell you? Going to next slide. So then about preventing common SQL Server performance problems with smart capacity planning. So we can really affect actually the SQL Server performance, and we can either do some bad things about it or good things about it. And when we are doing the good things about it, we are having, of course, software that is automated and plans the capacity as precisely as possible. So here we can see that which are the typical performance problems when we have had a poor capacity planning or we didn't plan the capacity. So we may end up to insufficient storage performance, we have latency issues, IOPS are hitting the ceiling of the storage system, then we may have also too high throughputs there. And of course, this all hits the big time the performance of the whole database management system. We may have memory problems like RAM utilization on instance level. We may have problems with the buffer cache hit ratio. It starts to degrade. Page life expectancy goes down, and then we are in a big trouble. And also, this is kind of a bad circle because it's circling then to insufficient storage performance because we are using more storage in that particular case, so they are related to each other. And then, of course, CPU is also quite common problem. We may see big processor queues and also too high level of CPU utilization on those particular instances and servers. So this is the typical problems on those servers that we did not make the capacity planning that well. But good news is that there is methods to avoid this, and which are the benefits of advanced capacity planning, and I refer here, for example, our SQL Governor software, is that you're able to understand the baselines in terms of different kind of heat maps, and you understand what is normal in your system, what is not normal there, which are the desired threshold levels you should apply for your future platform in different servers and instances and databases. And then you end up having much less performance and availability issues, because the trend extrapolations and benchmark extrapolations make the calculations of the capacity very exact. So it helps there a lot. You end up having cost savings because you don't have to put that much extra buffer, extra margin on your capacity plans, because they are more precise results, and you can have a different kind of scenario in there. You can compare, for example, different hardware or which kind of servers you're going to use there, and so on. Then, of course, because of the automation, you don't have to use months and months to do the capacity planning. You can do it in from few hours to a few days. So it's big difference there using software instead of manual exercise. Okay, and then some highlights of proper capacity planning method and software, what you should take in count. So one is long-term monitoring data. You need to have enough time series of performance counters in order to understand the seasonal characteristics of the data and understand the behavioral patterns of the data. Trend and benchmark extrapolations are very important. Then you understand how the workload behaves over years. And then, of course, the automation is element that is a no-brainer here. And machine learning makes the most out of by automating the most difficult things, for example, finding optimal SQL Server instance restacking on the target servers. And then, of course, you have to be able to compare the baselines between old and new data platform. What was the capacity when before I did the migration? What was the capacity after that, and how I can maintain the certain capacity levels there I want to. And then, of course, continuous lifecycle management, which is monitoring different kinds of alerting, predictive alerting, also SQL query tracing, diagnostics, capacity management, plan cache analysis, all this kind of stuff. So, and now in the end of my presentation, I will show you some excerpts from the SQL Governor software. For example, here I'm having a comparison of baselines between old and new data platform. So the blue line is representing the CPU consumption of the certain SQL Server instance on that source server, and the purple line is showing the actual utilization after the migration. So there is a annual comparison of those, and it looks very good. And then there is also memory usage comparison on those servers. So you can get any instance level performance counters and compare them, so you get the easy grip of how the actual migration went there, or the consolidation project went. And then, for example, here we have heat maps. You can drill down into individual instances, and just quickly by one fast view you can understand that what is the capacity utilization on your particular environment, and which servers are long tail to a level where the capacity starts to be on a too high level of consumption and things like that. So we have different kind of heat map reports there. And then this is one cool thing from our software. So we are having about 10 different kind of alerts in monitoring. We have normal alerts and warnings. Then we are having different kinds of consecutive alerts. Then we are having SLA-based alerts, self-adjustable alerts based on the baselines of the servers. But we also have predictive alerts. So one is based to linear regression, as we can see here. It says that, for example, this linear regression says that average momentum of this workload is going to be on warning level around 5 o'clock in the evening. This is European 17, so 5 p.m. here. But on the other hand, we also have quite cool feature called pattern alerting. So this pattern-oriented alerting is machine learning-based alerting that learns from your own environment, and it finds out certain patterns that with certain probability will cause or could cause you problems that with bare eye you cannot see. And because of that, we actually get a warning here already 12:30, and we can see that there is something not nice going on with CPU usage. So we have more time to react, go for the planned cache analysis, go for the traces, check out the weight stats, how they have evolved, and things like that. So this kind of functionality we, for example, have in SQL Governor software. And then my last slide, this is actually excerpt from the dashboard. You can see different kind of alerts and predictive alerts here on one page. You can have a planned cache analysis. You can see that, for example, this procedure called oops is constituting quite much of worker time here at the moment. And you can see the blocking, locking queries and things like that. And this is actually pretty much my presentation. Thank you very much from my behalf. And I now give my turn to Devon or Jeff.
I'll take it on. Devon was having technical difficulties. Thank you very much, Yanni. For those of you who are attending, this does wrap up the webinar. We will be doing additional components of this where we do deeper dives and cover more issues in large database environments. We do anticipate those for May and June. Follow Soaring Eagle on LinkedIn for those dates if you're interested. If you shoot us an email, devon@soaringeagle.guru or sales@soaringeagle.guru, I will get you a copy of the presentation, and when this is available up on YouTube, we will also have replays of this in case you have friends who couldn't make it or you'd like to look at it again or show it to somebody else. That said, one other thing that we're offering to those people who are on this call, not necessarily the ones who are reading this later or watching it later, I'll open up my schedule and give any of you half an hour free call, talk about any database related issues. I've been working with databases, performance and tuning for over 30 years across a lot of different verticals. I'm happy to help. We can talk about architecture, scaling, performance, something that's bugging you, staffing. You let me know. Shoot the email to Devon or to sales@soaringeagle.guru. We'll get it set up. Hope to have you at our next webinar. Thank you very much for coming and have a fantastic rest of your day.